Hello everyone, welcome to the presentation of the paper Discovering Music Relations with Sequential Attention. This is a work by Junyan Jiang, Gus Xia from New York University, Shanghai, and Taylor Berg from the University of California, San Diego. Music is a kind of sequential data with long-term self-similarity between phrases. To model long-term relations, attentive models like transformers are introduced to capture them. Such models adopt an element-wise attention mechanism to gather information from similar tokens. However, they cannot capture sequence-wise similarity in a single layer. Such limitation makes the model hard to learn the structural nature of music. Therefore, we call for a module that directly models sequence-level relations to better discover and utilize the deep structure of music. In this paper, we propose a new attention module, the sequential attention module. In this module, the queries and the keys are no longer elements, but sequences. By performing a sequence-wise comparison, the module will tell us whether these two sequences are matched, as well as the transformation that converts the key sequence to the query sequence. The architecture of this module is as follows. Imagine we have two sequences. The first one is C4, D4, E4, C4, G4, and the second one is A3, B3, C4, A3, and a question mark. You can tell that these two sequences form a tonal sequence relation by performing a token-wise checking, and we can use this relation to predict the unknown token. The module does a similar job by first stacking two sequences together and then feed them into a unidirectional LSTM. The output of the LSTM and the last key token will be used to determine the matching score of the two sequences, as well as the predicted embedding for the known token. We can use this module in an attentive language model. To predict the next token in a partial sequence, we will regard its suffix as the query sequence and its substrings as multiple key sequences. We aggregate the prediction from different key value pairs by a weighted average layer. The attention weights here are the normalized matching scores. For the task of conditional sequence generation, like generating melody-given chord sequences, we propose the conditional version of the sequential attention module. In this module, the relations of the condition sequences are also considered. This module contains two LSTMs, a forward LSTM to capture the relations of both the samples and the conditions, and a backward LSTM to only capture the relations of future conditions. We showed by experiments that the one-layer sequential attention model outperforms a three-layer transformer model with relative positional encoding in the next token prediction task. For the conditional sequential attention module, we also performed a generation experiment to demonstrate its effectiveness in capturing self-similarity in both the sample sequence and the condition sequence. Some important tasks are left as future works. First, the module can only capture music relations where two sequences align well in time. This is not true for music relations involving retrogrades or speed changes. Therefore, a new design of this module is required to capture them. Second, it is also worth exploring whether the module can help us in other music analysis and generation tasks, such as automatic music segmentation and automatic music accompaniment. Thank you very much for your attention. The codes and pre-trained models of this paper are available at GitHub. If you have any questions, please do not hesitate to contact us.